Hello everyone! We're continuing our deep dive into C++, and this time we're looking at some new keywords, static extern and the term linkage, which is closely tied to them. But instead of jumping straight into definitions, let's start with an example. I've got two files. In one file there is the main function along with some global data, a variable, a constant, and a couple of arrays. Last lesson I told you that global data can be accessed from anywhere in your project, but I didn't actually show you how. Now it's time. Don't worry, we're not officially starting multi-file projects yet, we'll do that when we get to the header files lesson. Still, it doesn't hurt to start experimenting a bit. So, I've got two CPP files. The first one contains the global data and the main function. The second file has a separate function. That function's job is to print out all the global data, but to do that it needs access to those variables. And for that to happen, the compiler has to see the global data in that second file. Remember, C++ compiles each file separately. Then the linker comes in to connect everything, linking up the functions and variables from different files so the program knows where to find what when it runs. In the main file, we've defined the global data. I've told you before that there's a difference between defining and declaring functions. A definition is where you actually write out the code of the function. A declaration is just the function header, no body, no implementation. You need declarations so you can call functions across different files. Like in this case, if I want to call a function from the second file inside main, I can't just call it outright, the compiler won't recognize it. That's why I need to declare the function before main. Once I do that, the file compiles just fine. Then the linker checks if that function is actually defined somewhere, and if it is, boom, the program runs. It's the same idea with global variables. If you define global data like this, that means it physically exists in that file. That's its definition. And if you want to access the global data from another file, you have to declare it, but this works a bit differently than with functions. To declare a variable, you need to write the keyword extern, then the type of the variable, and its name, and that's it. But if you also assign a value, any value, it's no longer a declaration, it becomes a definition. And you can't define the same global variable more than once, or a linker will throw an error due to ambiguity. So let's go ahead and copy our variable and array declarations into the second file, remove their initialization, and add the keyword extern in front of them. Now, in our main file, they're defined, and in the second file, they're declared. And just like that, we can use them anywhere in that second file. Let's write some output statements in our function to print the values of these variables. And also let's try running the program and see if it works. Everything works fine. But why did I only do this with variables? Let's go ahead and try with constants too. I'll remove the initialization and extern and write two more print lines in the function. Now, if I run the program, boom, the linker throws an error. Why? Well, global constants are a little different from regular global variables. By default, constants are only visible within the file where they are defined. You can use them in any function in the same file, but not in other files. There are two common ways programmers work around this. The first, the most common, is to define constants in the header file. But we haven't covered header files yet, so for now we'll use the second option. Just add the extern keyword before the constant's definition. That tells the compiler, hey, this constant should be accessible from other files too. You can also add extern in front of regular variable definitions, but since variables are already visible by default, it doesn't really do anything. Now, if I run the program again, everything works. By the way, functions are also globally visible by default across files, even though you can add the extern keyword in front of them too. But just like with variables, it doesn't actually change anything in that case. Let's move on to the next project and the next keyword, static. This one shows up all over the place in C++. For example, it's used to create static variables, static methods, and static functions. We'll cover all of that in separate lessons, but right now we're focusing on visibility, and in that context, static does the opposite of what extern does. You can put this keyword in front of a variable or a function. Let's start with variables. In C++, we have both regular, mutable variables and constants. By default, global variables are visible to all files in the program, but if you put the keyword static in front of a variable, it limits the variable's visibility just to that file. Now it behaves like a constant. You can only use it in the file where it's defined. Let's try running the program. Over in our second file, we try to declare that variable again. And when we run the program, bam, linker error. Why? Because when the linker processes the second file, it can't find the variable's definition. We hid it inside the main file using static. As a reminder, constants are already hidden by default. They're only visible within the file where they're defined. You can technically add static to a constant too, but just like adding extern to a variable definition or a function, it doesn't do anything. Think of it as if static is already automatically applied to constants. Now, let's talk about static functions. By default, functions are visible across all files, but if you put static in front of a function definition, it becomes local to that file. It gets hidden. Why would you want to do that? Well, let's say you're writing a helper function that's only supposed to be used in this file. If you don't make it static, it adds clutter to the global namespace, and you won't be able to create a function with the same name in another file, even if it's a good, descriptable name. That's why it's a good habit. If you're sure a function is only meant to be used inside one file, mark it as static. And here's a bonus. Static functions don't need prototypes. You can just define them right at the top of your file. That's because function prototypes are usually placed in header files, separate from where the functions are actually implemented, and static functions are meant to stay out of headers anyway. Now, let's get a bit more precise about how data gets hidden in C++. There is a concept called linkage, which basically defines where an entity, like a variable or function, is visible. It's similar to scope, but on a more global level. There are three types of linkage: external linkage, internal linkage, and no linkage. External linkage means the entity is visible throughout the entire project, in all files. By default, global variables and functions have external linkage. Internal linkage means the entity is visible only inside the file where it's defined. Global constants have internal linkage by default. No linkage means the entity isn't connected to any file outside its scope. These are things inside functions, basically local data. So when you add the keyword extern before a global constant definition, you're changing its linkage type to external. And when you add static before variables or functions, you're changing their linkage to internal. But don't forget, extern isn't just about linkage. It's also used to declare global data from other files. Without extern, you can't access globals defined elsewhere. So if you're working with the same global data across two or more files, here's the golden rule. Define the data in one file and declare it in the others using extern, and don't initialize it in the declarations. We're not done with the keyword extern yet. Sometimes in code you might see expressions like extern C or extern C++. For example, if you look at the definition of cout or cin, you'll notice extern C++ and that long line. What does that mean? Extern C and extern C++ are part of how C++ manages language interfaces and relate to something called name mangling. This matters if you want C++ code to talk to C code or vice versa. Starting with the extern C, it's a special construct that tells the compiler to use C-style calling conventions and naming instead of C++ style. This doesn't make the function global. Here, extern isn't about visibility but about compilation and linking rules. Why is it needed? In C++, function names get mangled. The compiler adds information about parameters, namespaces, and more to support function overloading. For example, function names get transformed into complex encoded names. C doesn't do this. Names stay as is. So, if you try to link C++ and C code without disabling mangling, the linker won't find the correct function because the names won't match. How to use extern C? For example, if you want to call a C function from C++ code, you declare it with extern C to tell the compiler not to mangle the name. Or if you define a function in C++ that you want to call callable from C, you mark it with extern C. To sum up, when you see extern C, it means the programmer either wants to use C functions in C++ code or write C++ functions accessible from C code. You can also write extern C before variables. Now, about extern C++. Like in cout and C, this is basically the opposite of extern C. It tells the compiler to use C++ rules, including name mangling. Usually you don't have to write extern C++ explicitly because all C++ code is already C++ by default, but sometimes libraries use it as a safeguard in case their headers are included inside an extern C block. Why do we see extern C before cout and cin? The standard library developers use it to prevent errors. Even if you accidentally include IOStream inside an extern C block, these symbols remain treated as C++. The most important info: do you need to use extern C++ yourself? No, almost never. If you're just writing normal C++ code, you don't need it. Unless you're working with extern C and C interfaces, you can forget about it, which covers 99% of C++ code out there. So if you don't fully get it now, don't worry. Some of it will stick over time, and that's what really matters. And that's it for this lesson. Thanks for watching. If you liked the video, feel free to hit the like button, leave a comment, subscribe to the channel if you haven't yet, donate via the link in the description, or become a channel sponsor to get access to practical lessons. Goodbye.